Previous video was binomial distribution. Now we will discuss normal distribution, the most frequently occurring type of data and probability distribution is the normal distribution. A symmetrical bell-shaped curve defines it. However, under the influence of significant causes, the normal distribution too can get distorted. This distortion can be calculated using skewness and kurtosis. We will cover skewness and kurtosis after this session. Normal distribution, continuous probability distribution, that is symmetric about the mean. It also known as the Gaussian distribution. A symmetrical bell-shaped curve, most value cluster around the central peak and taper off symmetrical towards the extremes. It is the characteristics by its bell-shaped curve. Suppose if take all the students of your class, make measurement the height of the student, most student will be average height, that graphical representation most value will be middle of the graph. This is the middle of the graph. Then very small number of the students, very short height and very tall height of the student is the extreme of the gap, and here. So you can see this is the bell-shaped curve. Bell-shaped curve, most value cluster around the central peak and taper off symmetrical towards the extreme. If we draw the vertical lines, this one, vertical lines on the mean, then mirror image, that's why it is symmetrical. Like this portion is the mirror of that portion. The normal distribution represents the behavior of most of the situation in the universe. That's why it is called a normal distribution. It also known as Gaussian distribution. Is a continuous probability distribution that is symmetric about the mean. The distribution is defined by two parameters, the mean mu, which indicates the center of the distribution, and the standard deviation sigma, which measures the spread of the data. The distribution is commonly used in statistics for various applications including survey analysis and quality control. Key points of normal distribution: the mean, median and mode of the distribution coincide. The curve of the distribution is bell-shaped and symmetrical about the line x equal to mu. The total area under the curve is 1, exactly half of the value to the left of the center and the other half to the right. This distribution is commonly used in statistics for various applications including survey, analysis and quality control. A normal distribution is highly different from binomial distribution. However, if the number of trials approaches infinity, then the shapes will be quite similar. Fx is probability density function and x is random variable. The PDF mean probability density function of a random variable x following a normal distribution is given by where fx, actually this is bell-shaped curve, so fx mu and sigma equal to 1 by sigma root 2 phi e to the power minus x minus mu square by 2 sigma square for x between minus infinity to infinity. Here x is the variable, mu is the mean, sigma is the standard deviation, e is the base of natural logarithm approximately equal to 2.71. Next come to a standard normal distribution. A standard normal distribution is defined as a distribution with a mean of 0 and standard deviation of 1. Here mean equal to 0 and standard deviation equal to 1. For such a case, the probability density function becomes fx equal to 1 by root 2 phi e to the power minus x square by 2, where x between minus infinity to infinity. The empirical rules tells you what percentage of your data falls within a certain number of standard deviation from the mean. 68% of the data falls within one standard deviation of the mean. Mean this one from here to here. 68% of the data falls within one standard deviation. Mean mu minus sigma to mu plus sigma, and 95% of the data falls within two standard deviation of the mean. Mu minus 2 sigma to mu plus 2 sigma. %95% of the data falls within two standard. %99.7% of the data falls within three standard deviation. That is mu minus 3 sigma to mu plus 3 sigma. 99.7% of the data falls within three standard deviation. Average Indian Premium League player retirement age. The distribution of retirement age of IPL players in normal distributed with a mean of 33 years old and a standard deviation of about 2 years. So we can get distribution of IPL player retirement age thus like a bell-shaped curve. maybe some player like MS Dhoni. His retirement age maybe 44 plus. So you can see this on the bell-shaped curve. Next video is very important, that is standard normal distribution and hypothesis.